Hello, everybody. I'm Jac, work for Cantic as a solution engineer. I'm going to tell you a bit about what we see, what's happening with CDNs, especially the embedded CDNs over the last couple of years. So we have seen growth in the market due to customer demand, more OTT services and entertainment services that end users are using. And the CDNs have played upon that and have been growing over time. There are some well-established legacy players. We all know them. And there are some newer ones that are providing services, more specialized services like DDoS mitigation or real-time delivery services, streaming events and things like that. The larger content producers not only rely on a single CDN, they distribute their content over multiple CDNs, both to support the different type of content, but also to leverage the geographical scope and the spread over the various regions that the CDNs are covering. So who are we talking about? I think we all know them. Don't want to spend much time on this because I think we're more interested in the statistics and how the CDNs are operating and providing us the content that our end users are actually looking for. So most ISPs that we have in our sample, in our data source sample, have 6 or less embedded CDNs in their network. The top 6 of those are, well, almost FANG, but not almost, but not entirely. It's Google, Facebook, Netflix, Akamai, Apple, and CDN. Those are the 3 top players that we see in the CDN world, and the amount of traffic that they're serving. The graph on the right side shows a couple of more, but you see the majority is being done by the well-known CDNs and by the big players in this market. So how is the distribution of traffic? So how does traffic reach your end user? What we see on average is that 74% of the traffic comes in over the external networking border. 14% of the total traffic comes from embedded servers. We see some traffic between the embedded servers inside the networks, and there's some traffic coming into the embedded servers as well. So most of your users are still being served by the traffic coming over the border into your network. That is on average. If you look into more detailed statistics, if we look at Google, for instance, you see that a lot of traffic, or more than half of the traffic, is being served from the embedded servers. Same for Netflix, same for Facebook. Akamai is a little bit different. It's also depending on which content is being served by the CDN. But for the traffic that Akamai is serving, a lot still traverses your network border. Google and Netflix have an interesting bit, and that is that they are serving their embedded servers from other embedded servers within your network. So how is your end user being, so what is the way that your end user gets the content from a CDN? There's several ways to steer that traffic to a cache that is in your network. Of course, we all know about BGP. That's our daily job. And also the caches use BGP to determine which cache is eventually serving the traffic for your end user. But there's more to it. There's DNS servers. So what DNS server is your end user using, and the cache that is responding to that request looks at what DNS server has been used Then there's anycast, an anycast address. So which is the which is the cache that is closest by your user based on anycast addressing and anycast routing, or geolocation. So the caches do a lookup. Where is this user from, and which cache should then send the traffic back to your customer? There's also some more magic. There's the applications itself that look at network performance metrics. The caches that serve the traffic also have some magic in there based on latency or quality of service data. Looking at the load of a certain cache, maybe it says, well, I'm too loaded now. Have another cache or another embedded server take care of this traffic for me. And also the content. Not all content is available on a cache or on an embedded server. So it's also depending on what content your end user is looking for. So what are the traffic profiles? So we're looking at typical Netflix traffic here, which is optimized to reduce the edge fill, so it's as little as possible traffic over the edges of your network. So try to have the caches send as much traffic as possible. So the blue lines here, I'm not sure you can read it from the screen, but the blue lines indicate the amount of traffic being served from the cache, which is not traversing the border of your network. So there's a huge optimization possibility here. The green, orange, and red line are traffic within, between caches, or traffic traversing your border, either directly to an embedded cache, or the cache fill, or directly to your users. So you see that a Netflix cache has little traffic crossing the border of your network. Similar for Akamai, although you see a little bit more traffic. So the green and orange and red line. So there's no red line here. Sorry. So the green and orange line, which is traffic to your users over the edge of your network, is a bit higher, and that all has to do with the type of content that they're providing. So not all content will be at the embedded service. We have another example for Facebook that has to do with the static and non-static content. So the feeds and the likes and the things like that, they are not cacheable. They are all being sent from the Facebook service. So you see a different traffic pattern here. So when you need to deploy, or when you're thinking about deploying a cache in your network, there's a couple of things that you have to keep in mind. And I explained that there's different ways of determining how a cache is being addressed with BGP or Anycast or whatever. So your network needs to support all those kinds of technologies. And you have to be aware of clustering. So where do you deploy the caches within your network? Do you centralize those, or do you spread them over your network? So it's not just like, oh, we want to have a cache, let's put it somewhere in the network. You got to know how they work, how they operate, how the steering methodologies are, and what the techniques are for serving your end user to optimally place the caches in the network. So is it easier or harder nowadays compared to, like, say, 10 years ago to deploy a cache? I would say it would be easier, although the technology has become more complex with all the different steering technologies. Hardware-wise, the boxes became smaller. The offload is more predictable. We just looked at it in the graphs. There's many players, so there's a lot of choice. There's a lot of options, and there's also some carrier-grade NAT support nowadays. I would say, what is your experience? So any questions on this, or any remarks, any thoughts?
If not, well, you'll be around in the...
We'll be around. We have a booth in the coffee area, so come on over if there are any questions. We'll be here the rest of the day. So yeah.
Okay, thank you very much, Jack.
No worries.
Cheers.